Uh, Hello everyone, welcome to another problem session. So today we are continuing our problem from the 2024 JEE 2024 JEE this advanced physics paper 1. So this is actually a very interesting problem, and it actually tries to address a difficult part of rotation that often gets not talked about much. You don't get to practice a lot of problems. Um, so what it is uh, reading the problem. I said you have a rod here, which is this black thing here, and the string, which is has a, you might say it's got some tension in it, but not. It's just taut. The string is just taut, and so anything hits it, the rod will start to rotate, and the tension is such that in the string, if there's the tension in the string is such that it will go in a circle. I mean, it will remain in a circle. That can be confusing. It just immediately go in a circle. So, like if this is t equal to 0 minus, then t equal to 0 plus, or delta t plus delta t is the time for this impulse. The impulse, you can say, instantaneous from 0 minus to 0 plus. This is what we're talking about. What will happen with the impulse? You get a rotational. Let's see, the rotational thing is going around uh, omega, be its frequency or angular angular velocity, angular velocity. At, at an instant after the impulse stopped acting. What will also happen is you have an impulse, so you can also look at it as a uh, center of mass, which is in the center of here. So there will be center of mass velocity. The center of mass is going in a circle with the same omega as omega of the whole rod, and but the center of mass is going at this radius. So the center of mass motion. So these are two motions that you can write down equation about. Okay. So the principles are angular impulse equals change in angular momentum. That's one principle. So what you might say, what is angular impulse? Well, angular impulse will be the impulse P times the lever arm, its lever arm, time its lever arm. Okay. So second equation, let's write down. Second equation will come from just impulse equal change in momentum of center of mass, as if the entire body was placed at the center of mass. Okay, so it says a certain mass. We just assume mass is m. Okay, so let's write down these two equations and then work from there. Let's mass equals m. So first equation is going to be p times, if you look at from here to is L plus a half plus x. So that's going to be x plus 3 over 2L. That's the lever arm because it is perpendicular. This R is perpendicular to the impulse force. and this is equal to change angular momentum. Okay, initial angular momentum was 0, so it's just going to be final angular momentum corresponding to I. So I about this point, about O times omega minus 0. What's I about omega? I about O? I about O is going to be so about axis this way, so we can do a parallel axis theorem. So let's put the omega outside on the left side, and over here a rod about the center of mass axis will be 1 over 12 ml square. The L is the length of the rod, plus it's this center mass to this axis, this distance. So m times d square, and d equals to where the center mass is to what the actual axis is. So there's L plus L over 2 equals 3/2 L. So if I do 1 over 12 ml square and have a m 3L over 2 square, so this is 9 over 4 plus 1 over 12, 1 over 12, 1 plus 27. Let me see. So 28 over 12, and that turns out to 7 over 3, 7 over 3. So this is 7 over 3 ml square omega. Okay, this part is correct. Okay, so I've got P times x plus 3 over 2L. This is one equation that's coming from. Then I need to do second equation for the impulse. Let's pick another pen color. So second equation will be impulse, just P equals to change in momentum. And change in momentum is going to be just m VCM minus 0. And VCM is going in this radius. So VCM will just be the distance to the center of mass, distance in mass from O times omega. And D we just figured out 3/2 L omega. You can see the units the same. So this is m 3/2 m L omega equals to P. So you got this two equations, number 2 and equation number 1. We need to find what x is. So if I take a ratio of this with that, unknown quantities are m, omega, and x. These are known quantities, and it will all simplify. So take a 1 over 2. The left side I get p cancelled out. I get x plus 3/2 L. On the right side I get 7/3. M cancels out. L remains. Omega cancel out. And 3/2. So you have a 14 over 9 L. So x turns out to be 14 over 9 minus 3. If I had not made some calculational mistakes, so this is 18, and 28 minus 27 L. So you have L over 18. I'm supposed to write as L over N. So n is 18. N is 18. Yeah, this was a good problem. It uses a good understanding of these principles. Okay, so this problem is done, and I'll be doing more problems later. If you have more questions or if you want to learn more of this approach of doing problems, you might check out this website. Okay, see you in next video. Bye.